Hi everyone, welcome to the third video in our 14-day introduction to satellite Earth observation. In the last couple of videos, so videos 1 and 2, we loaded up some Sentinel-2 data over Manhattan, and we looked at what it meant to build up this color image using these red, green and blue channels in the add map layer. But we stuck to red, green and blue, so we focused on that part of the spectrum that our eye is sensitive to, that we're used to seeing, and with digital cameras we're used to seeing pictures of this kind. But what if we go outside of what our eyes can see? Because one of the key things about these scientific sensors on satellites is that they're not just taking a picture, they're taking some quantitative data, and it goes beyond just what we can see with the human eye. So again, if we look at this data set that this workflow that we've got set up with the Sentinel-2 data set, we've chosen Manhattan on this area, but of course you can go anywhere in the world and you can choose somewhere else. You don't have to be stuck to the Manhattan area. We've selected a time period that's just the last couple of months, and we've got the masking out clouds and the aggregating images, so it's all compressed into one image. But let's look at this add map layer and the different choices that we have here on the different bands. Now the one that's, if you remember in the last lesson, we were able to look at single bands. We looked at things even if the green. So let's look at the green again to remind you that the green was slightly lighter. It wasn't a great deal lighter. It's still quite dark in Central Park, but it was a bit lighter than the blue. So I mean, the grassland came out as green in our final red, green and blue composite. Now let's just duplicate that add map layer, and this one we're going to look at NIR, which stands for near infrared. So this is beyond the red part of the spectrum. It's into light that our eyes are not sensitive to. Some insects can see into the near infrared, but humans can't see into the near infrared. We're going to look just at the single band, and you see that it's automatically named the layer NIR, near infrared. And we're going to have a look at what a difference that makes when we go outside of the visible part of the spectrum. Now you notice on the layers that I can also adjust the order in which these layers are viewed. So that's come up with the near infrared on the top, but I'm going to drag the green layer up to the top. So that's the one that we see first. And then if I change the transparency of that, we look down into the near infrared band. Now the key thing about the near infrared band, if I switch off that green layer, is look how much brighter it is in Central Park. And that's because healthy vegetation that's got lots of water in it and has got a healthy cell structure scatters the near infrared light extremely well, much better than any other wavelength that comes in from the sunlight. So healthy vegetation actually looks really bright in the near infrared. And that's a significant factor that we can use to draw out mapping areas of healthy vegetation. And one of the things that we're going to look at in the next lesson is the indices like the NDVI, the Normalized Difference Vegetation Index, that takes advantage of this very bright signal in the near infrared when you have healthy vegetation. So it means we can also combine this into a color image, but we're going to do what's called a false color image. So we're going to use multiple bands, and we're going to call this false color. The reason it's false color is because in the red channel, I'm now not going to put the red band, but I'm going to put the near infrared band in here. In the green channel, I'm going to put in red, and in the blue channel, I'm going to put green. Now, why do we do this? Well, there's a historical significance to this. It's because the very early infrared color photography that was designed to identify military equipment that was painted green as camouflage, but wouldn't reflect very highly in the near infrared. And so they developed color film to help identify in intelligence photography in the Second World War to be able to map where the military vehicles were. The way that color photography worked is that it put the near infrared channel into the red band of the color film. And so historically there is a standard where this false color image uses near infrared into red. And you'll notice the big significance here is that all the healthy vegetation springs out of the image as being very bright red. And it also helps to separate those areas that were also quite bright in the near-infrared, but they were bright in red and green and blue as well in the urban areas. So that doesn't mean that they're vegetation. But these areas, the little parks and trees in the urban areas of Manhattan are also now showing up. So in our next lesson, what we want to do is to tease out how we can quantify that and create an index that's going to help us map where the healthy vegetation is.